This is my all right, actually no, now I started recording. Okay. Hello everybody, I'm Justin. This is my spiel on the topic that nobody wants to talk about here called multiplayer development. And I'm gonna be talking a little bit about Unity, but this is honestly just a general spiel about like just in general the problems that you may face and some solutions that I've ran into and I've encountered when working on some games right now currently that are networked and multiplayer. So let's go. Actually, let's move on. All right. Yeah, so I guess here's the intro. I'm Justin. I'm not known around here as Justin. I'm known as Korn. I'm currently on leave, or yeah, I'm on leave of absence right now, but I'm still a senior at USC Games, interactive media and game design, and I've worked at a bunch of studios already, and one of the studios being Warner Bros, the other one being Airstrafe, and I'm also currently the lead engineer for Blindsight War of the Wardens, and I'm also the CTO of Test Jar Labs, and yeah, so working on a lot, and so this talk is mainly to discuss the problems that I've encountered when working on the game for my startup Test Jar Labs called Ghosty Battle for the Bones. It is a top-down MOBA fighting game mashup where you play as these little creatures called ghosties, and you can change your bone parts and wear different bone parts and fight each other in a big online battle arena type game. So yeah, let's move on to the next slide. So yeah, I'm just gonna go straight into this. Finding out, so the biggest actually challenge for me at first was figuring out the right networking solution to use for our game, because it requires different needs. So each game requires different needs for, the type of game that you're making. And for us, one thing that we really wanted was have excellent game feel with minimal latency. And we wanted to have really, really responsive input. So like if I were to press a button, it would automatically show that I pressed like the attack button or whatever, and it would show on everybody's screen and would seamlessly feel as if we were playing single player or co-op right next to each other. But there's a lot of information that we need to know first, and this is just a general like sort of spiel on what type of networking models are in terms of like how would they relate to what we're trying to build. And since our game, we want it to go like fully worldwide and stuff like that, we wanted to have players from different parts of the country come and play against each other. And these are the type of models that we were looking at first in order to help us with that. So the first one is peer-to-peer. And basically what peer-to-peer networking is where you have a computer like essentially host, and then other computers join over there and then send messages immediately to one another. So like, for example, if I'm on one computer and I say, oh yeah, let me press the shoot button, let me shoot somebody else, I will send to the other players directly that I press the shoot button, basically. So, and it's just a way of transferring. So like these models are just different ways of transferring messages across one another. And yeah, so the first one is peer-to-peer, and the second one is client server. And this is the main one that we're going to be trying to do because of the just what we want to accomplish with our game. And so what client server is, you're on one client, which is your computer, and then you send a message to the server saying, like, for example, I shot something. Then the server would then send the rest to the other clients. And that's just another networking model. And then we also have a listen server that just combines both of these. And yeah, it's not that this isn't really that important. It's just a type of networking models that you probably should be aware of when picking a software to use. And so once we figured out the model, what we have, and the question that we have to answer next is, how should our game be determined? Like, how should the state of our game be determined across clients? So what I mean by that is, let's say on client A, they shoot somebody or move to a different spot on the in the level, and the other client receives a message that this client moved to another spot. How do we know like which state to use, like between different clients? That's like the big question. And basically there's two ways to mainly do this. You could either network the state or network the input, and then deduce what the state is from the input. And mainly the two networking models, I guess, out there right now, or the types of networking that are out there include networking states and networking inputs. So when you want a network state, you're basically sending the output to the other clients rather than sending input. And what I mean by that is, if I press move forward, it'll move me to a position that is forward from my original position. But instead of sending the actual input of moving forward, we're sending the output, which is the new position, and sending that across clients. But in general, there's like a couple of problems with this in terms of, how do we know who should send the information in regards to state? Like, how do we know which person has the proper state, if that makes sense? So this is where what's called authority and ownership come into play. And what authority and ownership entail is that we give basically a client permission to edit the state of an object. And what I mean by that is, let's say on my client, I do not have ownership. Like, I am not authorized to make changes to the state of this object. If I try to edit this state, or if I, like, for example, if I tell on my client to take damage of, or actually, if I tell this player that's owned by another client to take damage, it will not take damage directly because we do not have control or ownership of this object. And so that's like just a principle of like behind ownership, to tell what state is valid. And so there's two types of like ownership or authority, I guess. There's client and server authority. So for client authority, you basically allow a specific client to have control over a state of an object. And so basically you have one person control the state of an object, while everybody else is just receiving messages from the client that owns the state, that this is the state that the object should be at. If we move on to here, there's client. So basically what I just described is client authority, and we have an example over here. But yeah, if we're saying that, so the whole reason behind authority is to maintain truth. And what I mean by that is, like, it's to maintain that, okay, this state of this object is the actual state across all the other clients. But the main problem with client authority is we cannot trust the people that are in our game, because they could hack, they could intercept messages and then send them so that they could hack. And it's actually one of the big problems in the game that I actually personally like, Minecraft, because they have this model, and there's a bunch of bad things that happen, like really funny things that happen on servers. But anyways, that's beside the point. But the problem here is, basically the problem is, clients can be hackers. How do we, like, and the question is, how do we only make sure that the sources of information that are sent from the clients is the truth? Like how do we do this? And the answer is, we don't trust any client at all, even if they're truthful. So we basically say, okay, the server is the only thing that can change the state of an object. And this is what's called server authoritative networking, which means that like if I need to fire a gun, I can't do it directly. I would have to basically send a message to the server that I want to fire a gun, and then the server will fire a gun and then send the message back to the other clients that they fired the gun. So this is like a form of cheat protection, but there is another problem with that. What comes with this is we lose the responsiveness that we get with client authority, because in client authority, you're basically assuming that you have ownership of the object and whatever you say is true. So if I press the fire button or I shoot somebody, I'm going to assume that I'm valid. I am the truth. So therefore, I will immediately shoot somebody. But if on everybody else, there's going to be latency. There's going to be a delay because it takes time for a message to go from a client to everybody else. So with server authority, since I'm not directly calling the fire button or the fire function, I have to basically wait a round trip for it to come back. So if I press shoot, the message is going to go to the server and then back to me, which is relatively slow. So how do we make sure that we still get the responsiveness back, even if we have this server authoritative system in place? And the way that actually some games do this, and I think most games do this, is with prediction. And what prediction is a way to ensure that clients feel responsiveness. And what it is it basically predicts the state of the object that you're trying to affect on the client side while waiting for the output from the server. So an example of this is over here, like in the slide. For example, I could move forward. The message to move forward gets sent to the server, and then the server is going to calculate the new position. It's also at the same time, the client is going to calculate the new position. And then when we receive the message back from the server, it's going to move to the position of the server. And this can result in actually rubber banding a little bit, because it gets the message from the server, and so it's automatically moving back to that position. Now I think a way that most games do this is via interpolation. So when you get the message back from the server, it'll basically move towards that position gradually instead of snapping to that position immediately. Yeah, these are most of the problems and solutions that come with state-based networking. Now, you can also look at networking as just sending over inputs. And this is actually how I believe most responsive games that have good cheat protection use. So they use they have what's called determinism. And to get determinism, what you need is to make sure that the input that you have at a particular frame is always going to result in the same output, no matter what device you're on. That's how determinism is. And basically how you would network it is you'd just send input and then you'd receive output. So you'd still receive the output, but you're only sending input. So it's not going to be as easy to hack, essentially, because you're only sending move forward or fire or whatever, rather than the actual state or output. But what comes with determinism is actually a lot of problems that existing game engines do not inherently solve. And the first one, the main problem is, how do we ensure that everybody's machine results in the same simulation of the game based on an input? So that's the main problem. So this is like for the more techie people here, but what you need to do is basically convert all your floats whenever you program. And for those that are non-technical, a float is a data type that represents a decimal, and it's encoded in a specific way on the computer. So what you have to do is you basically have to ditch floats, because on one machine, it could result in slightly different floating point numbers. So like, for example, on one machine, you could have like an output of 0.1, but on another machine, you could have an output of like 0.11 or whatever. And so the simulation would not be exactly the same. So because of that, you'd have to completely ditch floats, and you would have to do what's called fixed point. You have to use what's called fixed point floats, which are just integers encoded as floats. Because, and for those that aren't familiar with integers, they're just numbers, but they're encoded in a different way. And you would just use fixed point, which is a different way of encoding like decimal numbers. But yeah, this is a huge problem actually with Unity and Unreal, because they use straight floats throughout their entire system. So if you wanted to do a completely deterministic game, you'd have to essentially just ditch all the existing systems that are in the game engine. So like, say bye to Unity physics, say bye to like their update function or whatever. So you'd have to keep that in mind if you want to try to build your own. But luckily there is software out there that handles this. But anyways, the next question here is, now that we've made sure that we arrive at the same simulation on every person's client, no matter the hardware or device, how do we ensure that the simulation accounts for latency? So if you remember, the latency is just when you send a message from the server to the client. And whenever you receive a message, there's going to be a delay, because it's going to have to go from your client to the server, which takes a little bit of time. And then the server is going to have to send the message to all the other clients, which then takes a little bit of time. So we have to account for this. Now I believe there's mainly two methods that I found. And the first one is called lockstep. And this type of networking implementation basically just waits until all the input messages at a particular frame have been sent by all the clients and then received by the server. And then only when the server receives all the input from the clients, it'll actually run the simulation of the game and then send the output back to the clients. So as you can see, this is problematic, because for games that require really responsive stuff, if one player is really laggy, it's going to have to wait until that player sends input. And if one player has like 200 ms ping and one player has 10 ms, the game is going to always run 200 milliseconds slower than expected, because of the last client having 200 milliseconds. So that's one way to do it, but this is not the gold standard. The gold standard for this type of networking is actually rollback. And it comes with a lot of hype, but basically what rollback is you simulate the game on your client and simulate it on the server. And what you do is you basically send inputs to the server. The server would then, when it receives it, go back to the time at which you sent the input. So like, for example, if I pressed move forward at tick 100, and then the server receives it at tick 200, we would then go back in time to tick 100 and then redo the entire simulation from tick 100 to 200, which is, as you can see, probably has a lot of computational power. But it honestly, this type of networking results in the best responsiveness, because because you can hide the actual like latency really well from this, because you're just taking whatever input that you get. And since every client results in the same output for input, then the game will be smooth and you won't have any desyncs. And so, yeah, so with these concepts in mind, like, this is what I had to learn in order to figure out what type of networking I needed for the games that I was making. So yeah, so this is like the big question. And so, yeah, it's basically it with all these concepts in mind, it's definitely not simple. Like, you have to be aware of what's out there. And you just have to understand basically have good documentation as well to help you understand how it works as well. So yeah, for example, for Ghosty, the game that we're working on, I've had to research like 6 or 7 different networking software to figure out the right one for our game. And yeah, just in general how they work. And with all these concepts that we've discussed in mind, it's pretty, it's helped me a lot in terms of figuring out how to pick the right one. And just for those, and just like here, this is the type of solutions that are out there. We have, as you can see, the authoritative and state-based networking solutions out there. And these are the main 4 that I know of, that I've researched. And yeah, they're all pretty good. I've used netcode for game objects. I've used Mirror, and I've also used Normcore. And for authoritative and state-based networking solutions, those are good for like if you don't worry about like much cheating, or if you're not worried about like high latency spikes affecting the experience of your game. So like co-op games or stuff like that, stuff like Minecraft too, is good for the authoritative and state-based networking solutions. But for stuff like, where you need really, really precise inputs and really, really precise outputs, stuff like fighting games, stuff like MOBAs or whatever, this is where you would want to go with the deterministic and input-based networking, such as netcode for entities, which is Unity's actually in-house sort of networking solution that is centered around dots. And yeah, it's not fully there yet, netcode for entities, but it's getting there. And then we also have Photon Quantum, which is honestly my preferred. This is probably the best networking solution out there for this type of game, for like MOBAs and fighting games and stuff like that, because it has all the things that we mentioned before, like rollback. It has prediction as well. So your game would feel really responsive if you're trying to make some sort of fighting game or whatever with that type of software. And so, yeah, I mean, this is just plugging TestStar Labs here with the playtest and stuff like that. Please sign up with this QR code. And yeah, thanks for listening to my TED Talk, I guess. But if you guys have any questions, feel free to reach out. And yeah, questions, go ahead. Yeah. So for those who can't hear, the question was, is rewind basically used for lag compensation? And the answer is pretty much yeah. It's used as a way to re-simulate the game so that you end up with the state, a similar state to how the person that sent it was, if that makes sense. Is to re-simulate the game so that you get the exact same state as the client that sent the message, if that makes sense. And so it's basically a lag compensation thing. And I see there's a lot of questions in the chat too. The next one, trade-offs between using an existing library versus developing your own networking solution. Yes. So there is a lot of trade-offs between using an existing one. If you have like, because most of these networking solutions aren't, well, some of them, the ones that are authoritative and state-based, most of them are actually free. And so those are actually pretty good if you're trying to quickly prototype or do a proof of concept, because their documentation is really good and a lot of people use them. So there's a big community for stuff like netcode for game objects and mirror. And so you can get something off the ground running really quick if you're trying to do a quick proof of concept. But yeah, it honestly depends on what you're trying to do as well. If you're trying to build a fighting game and you're looking for existing solutions, and you have all the money in the world, go ahead and try to pick one of these and then you'll get something going really quick. But yeah, I mean, the trade-offs are basically just time and money, because like stuff like photon quantum is like really expensive to use. And yeah, it's basically time versus money type thing. And yeah, just going down the list of questions. Can you describe the difference between networking state and input again? So networking state is basically just sending away the outputs to other clients. So like if I move from point A to point B, it's going to send that my position, rather than like me sending to the other clients like, oh yeah, move forward. And then the other clients would then simulate moving forward and then coming up with a position on their own. So like it's basically sending input versus sending output. And sending input is more secure than sending output because people can change the output, if that makes sense. Does that answer the question, by the way? Am I answering all the questions pretty well so far? Nice. I'm gonna go down. So Steven asked one question. Does determinism that I described have anything to do with determinism in physics systems? Yeah, it does a little bit. So there's different physics softwares, if you guys are aware of, like physics and whatever. Like deterministic physics is basically the same thing. You pass in an input and then the physics system gets spits out an output. And for it to be deterministic, it has to output the same thing on numerous devices and hardware. So like it has to do with the same thing. So if you want to have a game that is completely deterministic, you're going to have deterministic physics. And unfortunately, the physics package that Unity has, and that I think Unreal has too, they're not deterministic. So yeah, does that answer the question? Nice, cool. And so the next question, so if I have a small personal project fighting game, is it feasible to aspire to determinism and rollback? Honestly, at this point, if you're trying to build something that's really quick and small, it's probably not feasible, if I'm gonna be honest with you. At least with the given stuff, because like basically what I've figured out was, or what I've learned from all this is, either the networking doesn't meet the standards of what I'm looking for in a fighting game, or the stuff that does meet the standard for a fighting game is way too expensive to use. So like it depends, honestly. So I wouldn't, honestly, right now in Unity, I don't think it's feasible. But what you can do, and what we're actually doing right now for Ghosty, is you could fake the responsiveness by just making everything client authoritative. And so like, for example, like you can just make the whole game, or most of it, be just like, okay, I press the button, I'm going to assume that it's true, send it to everybody else. But it's not secure because people can hack it. But then again, if it's a personal project and you want to demonstrate like a proof of concept or something, and you aren't trying to get people that have a lot of players, or you're not trying to get a lot of players for it and stuff like that, then it's probably feasible. Does that answer the question? Nice. Cool. I'll move on to the next question. Is this a new problem for MOBA games? Yeah, this is not a new problem. This has been a problem for like a bunch of games like that for a while. I'm pretty sure it's not just a MOBA game problem and stuff like that either. This is also what happened with Valorant as well. What they did was they at first released Valorant with for the most part client and server authoritative gameplay, where like if you shoot somebody, it's client authoritative. And when they realized that they got a lot of players and a lot of players were hacking, that's when they switched to deterministic gameplay and rollback. So it's not a new problem. It's just a problem to solve, like a really hard problem to solve, to be honest.
So Korn, if it's not a new problem, why there's no standard way of solving it? Or people already, or you're saying those free softwares already solving that problem?
So the free softwares right here do a poor job of solving that problem because it's less time that they have to put into stuff like authoritative and state-based networking. But for deterministic and input-based, it requires a lot more to go into it. So you'd basically have to build like some sort of simulation or way of simulating, like kind of like a mini game engine almost, in order for you to actually get the type of deterministic results that you're looking for. And so there are solutions out there, but for stuff like League and for stuff like, you know, all these other games made by AAA studios, they build their own because they have the manpower.
Okay. But then Unity, so from that perspective, Unity is supposedly, if it's a good platform, you should have support this feature because there are it's a common problem for all the game developers. And you're saying they're not solving that problem properly.
They're not doing, and they're trying to solve the problem. Well, trying, I don't even know if they are trying, to be honest with you, but they're trying to provide solutions for it, but they haven't built it up to support like extra things like rollback and other stuff like that. Like, for example, netcode for entities has the fixed point and the prediction already integrated and implemented in their system, but they don't have the other things that stuff like Dota and League have, like the rollback aspect. So I think actually rollback is on their roadmap when I last checked netcode for entities. But yeah, it's a really tough problem to solve because there's a lot that goes into it. And honestly, Unity is not that scalable for stuff like deterministic and input-based networking.
Okay, sounds reasonable. Thank you.
Yep. Cool. Nice. I'll move on to the next question. Can I talk about the connection between UDP, TCP, and how does it related to the server authoritative type things that I've said, like lockstep and rollbacks? Yeah, so there's a difference between a networking protocol and an actual like networking solution, if that makes sense. Like, for example, there is this networking protocol that Minecraft use called RackNet. And what a protocol is basically the means to send information across the network via UDP or TCP or whatever they want. So it's just a means of sending over stuff and establishing a connection between client and server. That's all a protocol is. And the networking solution is like the process of using the messages that are getting sent across the clients. So the networking solutions that you see, like netcode for game objects, Mirror, Photon Fusion, they're all built on top of networking protocols that the developers made. So yeah, they just use the protocol, if that makes sense. Yeah. Did that answer the question? All right, I'm gonna move on actually. Have you ever heard or used GGPO for rollback? If so, how does it compare to other networking solutions? I actually did take a look at GGPO. I've never used it, but I read their documentation. I'm pretty sure it does use some sort of rollback or determinism, but it's mainly used for a peer-to-peer architecture. So if you go back to the beginning, we have client server, peer-to-peer, and then listen server. I think GGPO is mainly peer-to-peer. That's what I read when I looked at it. But this was a while ago, and if you have any information on it, any more information on it, that would be nice. Yeah, but yeah, that's basically what I heard about GGPO, if that makes sense. Did I answer the question? Nice. Cool. I'll move on to the last question. Are there other common game engines that have better networking solutions than Unity? Honestly, I think Unreal has a better networking solution. It has the same sort of authoritative and state-based networking. It does not have support for deterministic and input-based, but the main difference between Unity networking solutions and Unreal networking solution is that Unity networking does not have prediction built in, while Unreal has prediction built in. So you can make a much better server authoritative game, in my opinion, actually with Unreal, with out of the box stuff that Unreal has rather than Unity's stuff, because Unity, you'd have to do some extra stuff in order to make it like have prediction and all these other things that we've talked about previously. But yeah, I mean, that's my take on it. That answer the question? Nice. All right, cool. I guess this is last question, maybe. No, so what is the current status on Unity netcode? To my understanding, Unity has various solutions depending on the amount of customization needed. Have you looked through documentation on their HL API and LL API? Unity right now has 2 networking solutions. I believe they're old networking. They used to have one networking solution, and I think it was called ML API or something like that. I forgot exactly what it was called, but that old one is deprecated, and they instead updated it so that it's now called netcode for game objects. And they also have another one for dots, which is their entity component system architecture, which is called netcode for entities. Those are the 2 that I've heard of. And those are the 2 that are actually supported by Unity. The rest of these that are on here are supported by third-party companies or third-party developers. And so yeah, I think Unity is improving on their solutions, but at this point, if you're actually, I'll take that back. If I think they're improving, if you want to go for like an authoritative and state-based networking, in my opinion, I think netcode for game objects is the easiest to use in terms of that front, because it's very similar to existing networking solutions that are authoritative and state-based. But and netcode for entities is getting there, but it's built off of it's built off of dots, which is not completely stable yet to use, in my opinion, for a production ready game. So yeah, that's like basically my take on it and status. Did that answer the question? Nice. And then for Theo, I've heard of Godot. Godot, yeah. I think it does have some networking. I haven't researched much into it, but yeah, I'm pretty sure it does have networking though. But yeah, cool. I guess that's it as far as questions goes, right? So yeah, I guess thanks everybody for coming out. And yeah, here's I'll just do it on my side.
Yeah,
Yes.
Oh, sorry. Thank you. All right. Wait, guys, before you leave. All right. Sorry. All right, everyone. Yeah. All right. So, everyone, thank you all for coming to the meeting. I just want to remind you guys that the upcoming weekend of April 1st, so the weekend of March 31st to April 2nd, is going to be our April Fool's Jam. And if you want to come up with some wacky or cool chaotic game, then come do our game jam. It's very low key. It's somehow even more low key than our newbies event jam. So feel free to come. Just make something funny. All right. Thank you all for coming. And if you guys have any questions, see you next after spring break.
Doesn't that timing overlap with VCE's like physical hexon?